So I am Adam Sullivan. I am coming from Change Healthcare. We've got some slides going now. So wanted to talk today about healthcare and how we at Change Healthcare have implemented a full-on DevOps data science team that goes, our data scientists are building out, using H2O, building out everything from healthcare claims data to EMRs, and taking our entire pipeline from beginning to end all the way into production. And so just to start off, I know that we're approaching like afternoon lull time, so I appreciate everyone hanging out, but well actually you can just raise your hand now if you want, but who here has gotten a medical bill or explanation of benefit and just upon reading it, just wanted to pull your hair out because you're like, how is this, gotta keep the hands coming, how is this $5,000 or how is this $200? Why didn't you apply my insurance? Really simple things, right? The thing that we're up against and the thing that our company has to offer is that we can solve these things, and not even with really sophisticated machine learning. What we're up against is decades and decades of hard and fast rules and other things. You can't have 4 tonsils taken out in a single day. We know that. But I was talking to somebody earlier today, and somebody was transported by ambulance twice, in the same day. So, they just got some crazy, ridiculous, insurance bill, and then they had to spend a whole bunch of time trying to solve that. And so the kicker in all this in healthcare, 10% you pay a 10% premium for that experience. So the experience of getting bad bills and having to go through just the whole administrative piece. So Change Healthcare, I'm not even going to ask the question of who's heard of Change Healthcare because it kind of comes up pretty infrequently. But the thing is, we've seen you. Change Healthcare has seen you. Earlier this year, we announced a merger of a unit of McKesson, their financial systems division, and also the legacy Change Healthcare organization, which I'll talk about in a minute. Basically, our bread and butter is that we serve a medical network, and I'll talk about what that means in a second, but there's a whole slew of opportunity that we serve the healthcare industry, from preventing fraud, waste, and abuse, to chasing down, helping hospitals work with their denials, risk management, a whole team of different business units that help support kind of the whole ecosystem of healthcare. And so Change Healthcare currently has 15,000 team members, and so this is probably the most interesting slide in terms of who we are. But if you can imagine, we have. What do we serve? Whenever you go through a healthcare encounter, your claims, they have to check your eligibilities. They have to submit your claims to the insurance companies. The insurance companies have to adjudicate the final end result of how it got paid and how the insurance applied and deductibles and all those things. Probably 4 out of 5 times in the United States, it goes through Change Healthcare. We're that intermediary. So we serve 5,000 hospitals, 130,000 dentists, 800,000 physicians, and it's really a matter of submitting your claims to the Change Healthcare network, and all the routing happens, in between. And similarly on the payer side, in terms of how many connections we have, healthcare records, all these different types of things that kind of flow through our network, and just 92% of top 25 hospital plans. Health plans use our services. We are kind of this intermediary driver of healthcare in the United States. We have a diagnostic and imaging division, 68 million diagnostic imaging studies managed annually. And through our network, probably the biggest piece is over $2 trillion worth of claims submitted annually flow through our network. So to say that we've got a big data problem is not an understatement, and it's a fun problem for us. And I just wanted to talk a little bit about So we've built up a team over the past 2 years to actually build out what does it mean to have artificial intelligence being applied to healthcare. And for us, we kind of found that there's 4 essential components. I just wanted to share a quick story. I had an advisor from college that she retired and recently joined LinkedIn. And she was telling me a story about how she's an adjunct at a college nearby. And she was thinking about, as she gives exams, the exams can come back, you get a 70%, an 80%, 90%. And that's on an exam that involves a calculator. And the calculator never comes back incorrect. It's only what we've put into it, essentially. And for her, she had this kind of clicking moment of the calculator's never wrong. It's us that are wrong. I got like a B minus on a quantum physics class once in college and just broke my soul. But we're up against what we're up against in healthcare, especially on the transactional side, is finite. They're deterministic rules that we're up against. So for us, we as a team we've kind of identified whenever we're developing out our team, and we've got 20 data scientists, a team of 20 data scientists, data engineers, software engineers, really, really advanced team. But how do we build this out, and what are the essentials? And so, between having a team, having access to data, being able to scale with cloud infrastructure, and then having enterprise support to be able to develop pilots and generate proof points. Those are our kind of essential, criteria for developing a good team. And with healthcare, that third bullet in terms of the cloud infrastructure is no easy feat to be able to develop out and build. So our team, we've just more recently started expanding our team within Change Healthcare. But what we have is a full DevOps data science team that generates, like I mentioned during the intro, the data scientists don't, build stuff in Jupyter notebooks and then toss them over to the fence to software engineers and data engineers. We are full on, hands-on, building out these solutions end to end, using a data lake, which we'll talk a little bit more in a second. But these are how we're building out our tools. And for us, I just wanted to share just 2 really quick use cases, and I'll talk more about what's on here compared to what's on the slides. But one of our use cases is that we have hospitals contract with us to they just as we mentioned earlier, everyone has a denied claim or something that just drives you nuts of why is this denied? Why didn't I get paid? We have a team at Change Healthcare that works denied claims on behalf of hospitals. And the amount of claims that they receive from hospitals, sometimes it might be their entire inventory of claims. And so if you can just imagine trying to wrap your mind around, sorting through 1,000 claims. And claims have, ICD-10 codes and procedure codes and payment amounts and all these different things. How do you actually, if you were given the task of here's 1,000 claims, which ones should we work, because we only have so many resources, work being, file an appeal on behalf of the hospital systems, versus which ones are just, dead money, basically. Our old flow was we would have individuals that would, analysts that would go through and sort through thousands and hundreds of thousands of claims to try to identify what to work. We came in, we used H2O. We have a handful of models to help us say which claims should we work on, which ones shouldn't we, and if they are incorrect, what's the value in terms of the the total potential. And this business unit, it wasn't a 5% increase in the overall business. It was a much greater impact to their top and bottom line in terms of actually working on behalf of hospitals to get to work denied claims that otherwise they kind of would have just left drift off into the ether. So and I just real quick, at the bottom it's a really simple concept that we kind of built out. It's like score a set of claims, procedure code, diagnosis code, payments, client. It's just an example. The probability that it's that there's some sort of error. All right, let's work that one. we have another use case that I wanted to share. We've got at this point, we probably have 10 or 15 actual production jobs that are in some stage between proof of concept and full-blown production. But we have, this is kind of like an email targeting click-through campaign. You basically you're working on behalf of a self-pay insurer, which would be somebody, some large corporation, let's say they've got 15,000 employees. And you get those emails where it's like, hey, it's time for your flu shot. That's a good that's a targeted advertising kind of effect of reminding people to get their flu shots. But how much further can we take that? Can we say, who's likely to have a knee replacement in the next 6 or 9 months, or who's likely to have a hip replacement in the next 6 or 9 months? And whenever you're talking about hundreds of thousands or tens of thousands or hundreds of thousands of patients, we just can't wrap our minds around what that actually needs to look like. And further, it's hard to use data to drive your decisioning of how to make these choices of who to target and who not to. And so this particular use case of predicting procedures, and let's say it's a knee replacement as an example, we pair this with another division within our company that attempts to go through and create targeted messaging and content to say, not just for reducing cost. This isn't so much like a high deductible health plan, let's try to save as much money as we can. It's actually to try to get the best quality of care, because sometimes, getting somebody to a knee replacement, overseas or something for $5,000 might not be the best course of care if you can, you want to have somebody that's going to have low readmission rates and not, less likely to have infection and those types of things. So this particular project that we developed, and this is a production artifact that we have. It's able to predict out who, create a cluster of members who are likely to have these types of procedures moving forward. So those are kind of just 2 high-level use cases of what we did, and I wanted to share a little bit about how we do it, because we think for healthcare that we've established, for healthcare in the cloud, healthcare in the cloud is kind of an oxymoron to some degree, but for us, we're really proud of the actual tool chain and tool set that we have, all the way from exploratory data analysis. All of our team members it's almost bring your own language, generally between Spark and PySpark, Python based. There was one guy who liked R and we had to kick him out, unfortunately. Just kidding. But so we tend to want to go Spark based, and this is because we developed out a data lake within Change Healthcare, a singular data lake, not one of those like data lakes all over the company. And what happens is we have different business units, and their data we can get into our system so that our data scientists can build out and develop the models and architectures that we need. And so we start, exploratory data analysis starts off in maybe Apache Zeppelin, Jupyter Notebooks to some degree. Feature engineering might occur there. And then using, different pipelines of modeling and exploring. We hadn't used driverless AI, and I apologize for not having that before we showed up here. But we've used AutoML successfully in Spark jobs to find out, to help us drive to what is the most appropriate model or set of models that we need for our particular data set. The business evaluation, I put this on here because one of the biggest impacts for us with H2O is that hands down, I've gone into business evaluation meetings with vice presidents, senior vice presidents within our company, and have pulled up Flow right there. For me, the Flow UI notebook is kind of a ground source of truth for how we evaluate models. We've had some team members that have kind of come in, maybe not exposed to H2O too much, and developed kind of printing a lot of statements of how do we actually evaluate a model. And for me, the Flow, as we're talking about models and it's fair game in any of our code reviews to say pull up flow. We want to see the evaluation metrics. So I've pulled this up. I've pulled up flow in meeting with people who aren't exposed to machine learning, and I've even on with clients, and it's been really successful for us because we can pick a point on the ROC curve, and then have the confusion matrix, and then immediately translate that in an Excel sheet to, all right, if you make this decision at this threshold, what does it mean for your business? And then right after that, it's like we go right into pre-production. Our data scientists aren't building out models. They're building them in such a way that as we're, if we say pre-production tomorrow, this model looks great. They shore up a few things. They might have an all-nighter, but they're able to push right into pre-production, which is all based off of EMR. And then we deploy our stuff through Rundeck, Jenkins to do the build, all those types of things. So that's our pipeline with sparkling water and how we're using actually building out models. So I think we have three data scientists from Change Healthcare hanging out. If you guys want to raise your hands, if you want to talk about DevOps and data science stuff, our team's here. So this is all right. So now the dreaded part: how do we deal with HIPAA, right? This is the big question. So the way that you contract with cloud providers is through HIPAA is through a BAA. We have those with anybody that hosts our data. So somebody like Amazon we would have a BAA with Amazon. Everything has to be encrypted pretty much everywhere it goes, and then all the data governance, data rights, all those types of things. Whenever we meet a vendor, and this actually happened with H2O. Whenever we, as a company, meet a vendor and they've got the latest and greatest, most amazing whatever, as we're shaking hands, we're saying, hey, tell me about your encryption and support for HIPAA and PHI, and a lot of times we just kind of get blank stares back. With H2O, they weren't. The really interesting with H2O was that they said, well, we're almost there, but we'll solve it for you. And so we worked with H2O to harden H2O. The stuff you see in H2O3 was hard to make it HIPAA compliant for us, was hardened directly by the engineers at H2O. And for sitting sparkling water on top of Spark, we have a completely compliant solution for any modeling that we want to do. And we're basically we're our own controller now. Some of the team has spun up 20, 50, 100 node EMRs and just went wild with building models. And we have because of this now, we have no limit to what we can do, which is just really amazing for us. For our particular team, within our workflow, a lot of our team likes to iterate quickly in Zeppelin notebooks, which is, it's kind of a choice between Zeppelin and Jupyter and whatever else you want to do. But we've worked with H2O engineering to be able to load in all the jars and anything else we need directly into our template so that we can build out directly in Zeppelin. We can train models directly from within our browser. Once you get to a certain point where you're building out your models, you can toss it over into embedding it into a PySpark job, or if you're using Scala, directly into Scala code, build out the jar or the deployment artifact. But for us, just whenever you're at that point where you've done some EDA, you have some feature engineering done, and you want to iterate quickly, we're right into Zeppelin, and this controls a backend that can be an H2O cluster. I think on the example that I have, we have so this is a 3-node Spark cluster that we have. Looks like it was up for 6 days. Sorry about that. So that's kind of our workflow in terms of how our team models. But the one of the things that is really cool for us is how we handle our batch processing. The use case that I described earlier about how we handle the denials, the denied workflow. We run that model, we retrain that model and run it kind of on a weekly basis on average, and we follow this kind of framework, and it only runs for 1 hour a week. And so in the old school data center mentality, you would buy some server or have some server hardware, pay quite a few $1,000s to be able to host and run this model. For us, 1 hour a week on Amazon is, I don't know the math offhand, but less than $200 maybe. So to be able to go into a, and this is one of the core concepts of the data lake, to be able to go into a executive meeting and say, well, and project planning, what's the architecture cost going to be? And it's like, well, it's going to be less than $500, just the cost to run EMRs for an hour a week. This is what we get to say, and the way we do it, basically, we have a file that's dropped within our process that triggers a Lambda function. I don't know if the laser, I don't think the laser works very well. It triggers a Lambda function. The Lambda function will spin up a H2O and Spark on EMR using the AWS architecture, and then basically train and score a model right there, return the results back, that's that bottom left corner, back to the data lake, and we'll also alert the supporting application that, hey, your file's done, and then they go in and pick it up. So the whole end-to-end piece, this is basically our method for how we want to handle our integration of our data lake across many different silos within our business, being kind of a centralized data science team. So the main flow is that it doesn't matter if it's on some on-premise Oracle database or Microsoft SQL Server or whatever it might be. We can have a supporting application, get our data into our data lake, we can do our processing on it and return the results back. We don't need to do a whole lot of specialized integration back into production workflows. So for us, and this isn't anything special to Change Healthcare. This is a very common, just how do you handle batch processing with EMRs, with on-demand architecture in essence. And so that brings us to what's next. And I wanted to just share just a really quick story that we're successful with H2O kind of over the past week. If you think about you think about the technology for text. So we're starting to get into, we have a lot of text across our company in terms of medical records and appeal notes and a whole slew of things around text. Even whenever you get an eligibility, it's just one big field of text coming back to you. And so if one of the things in the industry of healthcare has been a concept called computer-assisted coding. And if you don't know what computer-assisted coding is, it's just trying to auto-code some block of text to identify that these sentences make up a diagnosis of pneumonia, let's just say as an example. And the really interesting, we did an experiment where computer-assisted coding has been around for 10 or 15 years, and a lot of the industry leaders have kind of been in a realm of selling over that time frame, usually under kind of the nomer of NLP and those types of things. And so what we did was we took, we know that Word2Vec and deep learning couldn't have been any sooner than 2015 because Word2Vec only came out in 2014, let's just say, in terms of like being able to actually productionalize it. Before that, we were looking at TF, IDF, and GLMs to build out what our models looked like with text specifically. And so what we did was we kind of took the technology from 2007, let's say, to 2017, and just applied it across. And in terms of what other people are doing with coding, how far can you get with the existing technologies, and then how far does it look today? And really, we're just talking about 2016 and 2017, because Word2Vec was one thing, and then applying it to deep learning was a whole other component. And I'm not even necessarily talking about TensorFlow. I'm talking about the deep learning architectures within H2O and the Word2Vec incorporated in H2O. Using that, what you can code automatically using text and a diagnosis code, a procedure code, you're basically 2 or 3 times better using Word2Vec and deep learning. And this was our experiment that we ran out, and we plan to continue refining it. But for us, it really represents, and this was done with H2O, and we're basically, for us, we're going to double down on using H2O for our text-based applications as well as our claim-based applications, and for additionally, we do have a lot of models that have been developed out in TensorFlow. We're excited to see what the vision with H2O goes with that. And in terms of, we don't want to be, we last week we announced partnership with Google. We don't necessarily, as a Change Healthcare being integrated with Amazon, we want to have diversity across our portfolio of our technology and our stack. And we definitely, as we go through, we definitely want to continue exploring our options with EHR and medical records. Driverless AI for us represents probably the next big step in terms of what our strategy is. Our data scientists they're not proud of the specific model that was developed, or checking in some code with their name on, I developed this particular model. It's much more so a matter of the quality of things that we're building and the speed at which we're building those. And for us, the components that are quality and have high impact is what drives us. So there isn't so much a pride of, oh, I want to do feature engineering and I want this to look like, I want to be the guy that codes all this stuff. Using driverless AI and AutoML and those types of tools definitely represents the next step for us. And especially as we get into text, I know that there's some roadmap for H2O with text. So with that being said, that's the end of my talk. So if you guys are on your laptops, just hop on LinkedIn and connect with me, Adam Sullivan. And that was all I had. And I will be around. I'll be at we're going to talk a little bit in a half hour or so. We're having a panel here, so I invite anybody to ask questions or catch up with me between then. So that's all I got. Thank you guys so much.